Okay, so yeah, I think maybe I have not. Yeah, you have shared this. Okay, so this is your INMO 2023, and this is, we'll do problem number 3. Okay, so it's about finding it's about finding C's. Okay, for which C, so C belongs to real. Okay, and then there is a function, okay, from n to n, which has this property that A does not divide. Okay, A does not divide this. I mean, this should be x. Okay, and also A is constrained. So sorry, I mean, yeah, F is constraint. So fx minus cx is, again, this 2023 is I think that's just an arbitrary number. Okay, is this. So we have real number c and we have function f. Okay, so we want to ask, the question is, for which c does such a function f exist? Okay, so okay, yeah, maybe that will be also useful actually. Yeah, so the question is, for which c, so f is just a sequence, right? You can think of it as just a list of numbers, right, Ishana? It's just a list of numbers, but because it's, yeah, a1 a2 is f of 1 f of 2, just a list of numbers. So the question is, for which c does such a function exist? Okay, so this is so Ishana, is the question clear? uh, so yeah, I mean, I understand it's a very, maybe this is the first time you're seeing this kind of question, but yeah, I mean, I'm also probably seeing this kind of question for the first time. So for example, you can ask yourself that whether for 0 such a function exists. So you can try to see if for c equal to 0 does such a function exist. So my claim is that no, because I was able to do this. The claim is that for c equal to 0, no f exists. So you try to prove this, and yeah, so I'll just give me a sec. Yes, go on. Right, so c is equal to 0, so then our fx is constrained between 2023 and 0. Okay. And this is the key thing, that a does not divide. Obviously, for a not equal to 1, otherwise it obviously divides. It does not divide this for all a not equal to 1. So 2 doesn't divide f of 2 plus x minus fx for any x also, and for any a. Okay, so I will just tell you, I'm sorry, because this is a little, yeah, okay, but it's very easy. So what happens in this case is, this implies that f takes only finitely many values, right? Okay, nice. What does this mean? Well, this implies that there is some there is some x and y such that f of x is equal to f of y, right? Again, it's like a pigeonhole principle, right? And uh-huh. Oh yeah, so you've even the bound, yeah, right. Yeah. So yeah, so if you take inputs like 2023 inputs, then you will two things will repeat. Anyways, so now we are done, right? Because now this is 0, and so it's obviously divisible by, like, this is obviously divisible by x minus y, right? And you can also arrange x and y to be not x minus y to not be equal to 1. That you can do, right? I mean, so you can just pick from this set 1 3 5 7 dot 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 dot. Even from this set, two things output will be equal because there are only finitely many output. So you see, so basically this means that this is a contradiction, because we were not allowing this. Ishana, you can see, right, that this statement, to think of it, in a simple way, it is basically this statement, right, that x minus y divides fx minus fy, right? You can, yeah, so it's okay, like, obviously you don't have to write that proof of that, but it's good to think of it in that way and use it, and if needed, if you use it explicitly, then if you use it to just come up with a trick, then you don't have to explain it. But if you use it and you have to explain it, you have to explain it, but you should know it like as an intuitive fact. And this, as an aside, obviously you people know that this is a very important thing, right? For every polynomial this happens. F is a polynomial, then this happens, x minus y, this we have done. Okay, it's kind of congruences also, it comes up and so on, but anyways, so in particular we know that f cannot be a polynomial. that that would be like a simple, very very trivial question. Maybe some, yeah, anyways, some MCQ question. Okay, so we know that c equal to 0 is not possible. So here I'll just say very short, because now I have to also think. Okay, is here we are just learning that if f doesn't grow very fast, okay, then sort of things come closer and closer, like too many values in too small place. Okay, then this divisibility constraint sort of gets violated. Okay, yeah. So now you can try to think what to do. I tried to show that c equal to 1 is not possible, but I could not do it. Okay. Yeah. Oh, no, Nagesh, you should not join here. This meeting will end after 40 minutes. Okay, no problem. Yeah. Now, so it doesn't matter. Okay, cool. Okay. So Nagesh, we're just doing this INMO question. Okay. The other two people are on Google Meet, but that's fine. You should stay here. That's not a problem, because either ways now this will end in 40 minutes. So this INMO question is problem number 3. So you can. I'm not writing the question completely. You have to look at it if from the reference. Yeah. And yeah, we have proved so far that c cannot be equal to 0. Means for c equal to 0, no such function exists. So you see, the CX is a line, right? CX plus 2023 is like the line, shifted line, and FX is close to that. Yeah, I mean, look, this is very simple. Like, so if you think in a positive direction, then can you think of a function which really works for some C? So we have observed that polynomials don't work. Okay, because you know that x minus y divides x to the power n minus y to the power n. From here you can show that it divides a difference of any polynomial evaluated at two different points. That's fine. So f cannot be a polynomial. Okay. So now you can think of can you think of some natural examples without thinking about all the details at once? Can you just think of some natural examples? Think of, I'm just trying to prove something. I'll try. Yeah, this point was very no, sorry. Yeah. Uh, I Yes, I think we did one small thing wrong. So when we said that fx minus cx, oh no, sorry, that was right. Nothing. So try to think of some natural examples, or maybe try to think of a C that works. So what's the next thing to polynomials? Maybe like polynomials don't work, then what? So you cannot. So you also cannot have any exponential or quadratic. It's not polynomials. Any exponential functions, right? Because this they will violate this. Okay. So that is to keep in mind. Yeah, that equality will not matter. Uh-huh.
Trigonometric functions.
Trigonometric function. Okay, trigonometric functions. No. Yeah, n to n. So again, that's the thing, right? So if it's from n to n and it's not polynomials, and then what is it? So you can try to. Okay. Mm, okay. I don't have anything to say. Yeah, it is strong in one sense. It is strong in one sense. Yeah, but it. Right. Yeah, right. So if we take floor of x, then does that work? So this is pointless, correct. Right. Floor of x is pointless. So what should you do? Floor of x by 2? Just check. So what c should you guess for that? Obviously c equal to half. Right? There's nothing else, right? Yeah. And then it works, right? Right? And that's something that all of us know. This is between, you know that this is less than 0, bigger than -1, less than equal to 0, right? Ishana, how is this? Is this okay? Because we have not checked all the conditions. So our claim, our guess, at least so logically, let's see if this makes sense, right? That we take this function, okay? Just logically, let's say, okay. Then if we take this function, then this function works because fx minus, and the c will take half, obviously, right? I mean, it's also like that, right? For which functions does there exist a c? If you can do that, that's also fine, right? Then you basically found all the c's, right? So just take c equal to half. Now then you look at this. This is fx minus cx, right? And this is between -1 and 0. And you can check that the top one doesn't work. Like, okay, let's check this one, this condition. But right, so yeah, so you take it. So why will this be not divisible by a? It will be less than a probably, right? Or yeah, something like that, right? Yeah. I mean, it's like a by 2 almost, right? So it's less than a most of the times. So a will not divide. No, the difference will always be an integer, but it is sort of less than a. Yeah. No, because from end to end, so difference will always be integer, right? But yeah. Okay. So Ishana, is this example okay? Right? So yeah, I'm not saying that coming up with it is easy. That cannot be gotten in a second. But yeah, logically following the example. So okay, so we understand then that c equal to half works, and we understand the function. So uh, yeah, let's note down our progress. So c equal to half works, and we know the function. Yeah. Okay, maybe we'll say this like this. Okay, we'll write the number and the function. Okay, yeah, this works. But then if c equal to half works, so can you build on that to get other values of c maybe which work? So you can think of that. That will probably just be some sort of a translation of this fact. Yes, for the very same reasons, right? For the very same reasons, right? There is no magic now. For the very same reasons, this will keep working. I suppose you can just check it, but it should work, right? The difference will surely. You are right. So what I've written is wrong, right? So yeah, this, so n by 2 will not always work. So because we don't know, because yeah, so let us know, let us just be a little careful here. So we are taking 3x by 2, and for this it is 3 by 2. Okay, and similarly, like again, if you take 2x, then it will, if you take 2x by 2, that will not work, because uh, why will that not work? Because it will just give you 2x, right? It's not going to do anything. Okay, so what I'm just saying is that this is useless. This is just n, so it just becomes identity function, and that doesn't work. You can check. Yeah, identity function ke liye, there is nothing works. So okay, so then we have found a class of things which work. Obviously, we have checked it, and Aryan is given the examples so far, so that's okay. But let us now see. So we understand that this k plus half, where k belongs to naturals, and I'm not writing the function anymore, because I think the job of the function has been done. It can now rest. So this is like this. Okay, okay. This certainly this set works. Okay, for all this we have functions, and we have very obvious functions in a way. Checking is there, but it's obvious. Checking is also easy. Okay, okay. Now the next thing is, again, so going back to, so because initially I started with what does not work, and we were able to very easily show that c equal to 0 does not work. Okay, can we show that c less than half does not work? Okay, that is what, because, so the reason why I'm saying that is because, so the reason why I'm saying this is, you see, when you are, let's say you're looking at f of 1 minus, I mean, if you take it to be very small, then half certainly works, but if it's less than half, then what happens is the following, right? For example, let's take x by 4. Okay, so 1, then it's 1 by 4. Okay, so what do you get, right? You get this, and so you basically get that f of 1 is like this. Okay, is like this. Okay, but then the problem is that, you see, fine, at this moment f of 1 has a lot of space. Okay, it has a lot of values that it can be in between, but um what I want to say, yeah, I want to say that the values for possibilities for f is slightly decreasing, right? So it's like this. So it's 2 by 4, and then on this side it is um, 2 by 4. Okay, now really it is uh, how do I say this? How do I say this? Yeah, what I want to say is that the possible values for f of n plus 1 is not one more than the possible values for fn. Is that making sense? Right? Because if you look at f of 1, it had this range from this to this, but in fact it is just from 0. Right? It is from 0 to this. Okay, when you move to f of 2, it did not gain one extra value, right? It sort of gain half extra value, right? So is this intuition correct? Right? Yeah. So what does this mean? This means that there will exist a k. They will come to a point, you can find what that is, but there will exist a k where fk will have less than k choices. Where fk will be less than k. Are we sure of this? Okay, yeah. So let's be a bit more precise. Okay, this is sort of a intuition that comes, right? So for example, okay, you look at f of 1. So let's take c equal to 1 by 4. Okay? Let's take c equal to 1 by 4. Because see, the initial thing that we had when C was equal to 0 was the space problem. C equal to 0 combined with the inequality created a space problem which forced the divisibility to happen, right? So when it's like when you have few numbers and a few choices and large options in model, two things have same remainder and so on, so you get divisibility, right? But very simply put, if you try to follow this logically also, then you take C equal to 1 by 4, for example, then f of 1 के लिए what are the choices, right? It can be from 1 to 2023. Okay, now f of 2 has how many choices? Well, it is also from 1 to 2023, right? Tell me what are the choices for f of k? K by 4. That's it. Now I'm just saying it logically. Yeah, now it will be easy. Now you can see, right, that fk is less than k. Now you don't need the intuition at all. Ishana, is this okay? Right? But now you can tell yourself any intuitive story from here that you can sort of just say, okay, this is how it comes. Yeah. But yeah, because initially I was not sure of the bound myself. So yeah. So the point is that then this is easy, right? And in fact, what I'm just trying to say is that fk minus or rather k minus fk can be made as big as you want actually. K minus fk can actually will actually go to infinity. You can make it as big as you want. Means that compared to k, fk can be small. It will be roughly be 1/4, right? Will roughly be 1/4 of it. But then what does this give us? Yeah, what does this give us? Well, this gives us as many repetitions as we want, isn't it? Yeah, but then why? Like, how does it contradict the divisibility? That's what I'm not able to explain so far. That's what we have to just explain. It should contradict the divisibility, but how? I mean, sort of by the same reason, right? So I mean, if fk if so basically it is like 1, 2, 3 till fk, right? I mean, these have to go in between 1 up to k by 4, right? And so you will have enough repetitions, and so things will sort of cancel. You know, two things will be equal, so the difference will be 0, and so on. Is that fine? Yeah. No. Yeah, that's right. But you do not need modular arithmetic. I'm just saying that the numbers will themselves become the outputs themselves will be equal, right? So that's what I'm saying. So it happens for more general, more simpler reasons. So from f1 up to fk, you have k numbers, and they are lying between 1 to k by 4. So two of them or three of them, however you want, they will repeat, and you can ensure that the gaps are. You understand, right? So let's say that f of a equal to f of b, and you can ensure that a is not equal to b. Just try to see how you can ensure that. But I mean, you can understand. Yes. So you can ensure that the moment you ensure that, you are done. Then a minus b is not 1, but f a minus f b is 0. So this thing is contradicted. Okay. Like all the details, saying and calculating all the details at once may not be the best way to do the problem. I mean, at least for people like me, I'm like now slow in calculations and probably get slower and slower. Okay, but hopefully you can retain the important. Yeah, I mean that actually helps. Being slow in calculation helps you to think more freely in a way. But anyways, all those things. So basically, we show that C less than half, and you see the same thing will happen for C less than half. Anything that is less than half, right? The same thing happens. C equal to half, we cannot say that because then the growth is sort of by K, by sort of equal amount, right? So yeah, so you can give the same reasoning for C less than half, but I am saying that I have not proved it. Okay, this is something just heuristically. Okay, now, so let us say that we have shown that C less than half does not work. Then can we now use some translation idea again to show something? Yeah. So we have shown that C less than half, and in fact we have shown that C between half and minus half does not work, right? Now can we use some translation idea? Like, you understand what we are trying to show now, right? Maybe we'll try to show that C between uh, uh, between half and 3/2 also don't work. Yeah, Ishana, is this making sense what we are trying to do here? We have kind of, okay, like on a level, we have shown that this does not work. Points here do not work. Now we try to, because we earlier saw that translationary feature sort of, right? So we will try to show now that between half and 3/2 also they don't work. Okay. And that I suppose is very easy, because if something, I mean, that's because look at the question, right? If fx works, then fx minus 1 also works. Is that correct? I mean, if f works, then f minus 1, the function f minus 1, the function fx, the function gx, that is just 1 less than fx, that also works. Right? Wait, now I'm just, I mean, kind of. Maybe the constants, this constants will change, but that is fine, right? You understand that, kind of. Yeah. So, but let's try to then use that idea. Okay. So let us say, let's just take some value. Let's say that c equal to 1 works. Yeah, let's just do one example. Okay. Say that c equal to 1 works. Then I'm trying to show from here that the c equal to 0 also works. You see my point, what I'm trying to do? If I have this, then I will show that c equal to 0 also works, which I know is wrong. And we understand that's the spirit, but we want to just show it. And obviously, it may still be wrong. That method may not work. Then we have to track back. So if so, there is a function. So that's how these things are sometimes very strange. You cannot show it directly, but you can show it only by pulling it back to a previous case. Because in mathematical problems, that's the thing, the whole truth is never given to you, and you have to use the truth that is given to you to logically arrive at things. So we have to do all this translation and so on. We have to do, that's why proofs can be difficult, right? So if we have this, right, um, uh, then what happens? Yes, right. So if I want to reduce this to c equal to 0, then I'll just take the function fx minus x. Right. Consider this function gx. Right. And a does not divide f of a plus x minus fx. Well, that also implies that a does not divide gx. Right. A does not divide the same thing for gx. So you see, I've taken that to be gx for the very simple reason. I want to get to the case where c equal to 0. Right. So I've taken this to be gx. Right. Now you see, we know this, right? But then that implies also that gx plus a minus gx will also not be divisible by a. Why? That is very simple, because just write the definition, you would know, right? And you will know. Whatever. F of x plus a minus x minus a minus g, right? So f of x plus x, right? So this will be f. This and a you can also forget, and so you get a contradiction, right? So a was not dividing this, so it means this. But then this is basically the case of c equal to 0. Then you get a function for c equal to 0, which is a contradiction, right? So this translationary feature, we sort of, I mean, it's easy to see, but I got the idea from, maybe that's what Aryan was saying, that we can like create more examples. Or anyways, yeah, that's the way it's given. The differences I represent, right? Yes, certainly that. And I think that with the same thing, we can show that nothing like, yeah, I understand your point that here the one being a natural number was important. But I mean, what I'm saying now is that nothing in this works. And we can do the same translation thing to show that. So C between half to minus half, half to 3 by 2 will not work because minus half to half does not work. Okay. Hmm? Yeah. Then all the intervals. Exactly. And then basically we'll get that what you got initially were the only, and that's how it should be. I mean, yeah, that's how it should be. Yeah. And but then just finish this, try to finish this. So try to take something in this that works and somehow convert it to that case. Maybe you will end up with some rationals, some primes which you have to take care of, but do it. Okay. That should not be difficult. That's what I'm working on. So we have not completely completed the solution, but we are just, yeah. Okay. So yeah, so we did it mostly. Now we, yeah, move to the next one. Okay, no. So let's actually do fifth one, because I think Aryan is saying that he has some solution there. Okay. Yeah. Okay. Let me see, because I let me once again. So I have not read the question. Yeah. And I will also, let's take some 2 minutes, some 1 minute break. Okay. So what I'll do is, Nagesh, I will end this meeting and you have to join on Google Meet, because it's going to end, I think, in 5 minutes on its own. 10 minutes maybe, so it will not be good. Start the second problem from new board. Okay, just take a break, see what happened, think about, go over what happened maybe. Okay, uh, and maybe I'll leave this here if it's available. Okay, and meanwhile read the next question number 5. Okay, I'll just end this meeting and I'll just also come from the washroom. So Nagesh, you have the link?
Just
Yeah,
always
just
the same link,
yeah.
right, for now on?
Yes, that Google Meet link, because then the only thing is that this meeting then it ends in 40 minutes if there are multiple people. Yeah, and then also now there is a 5-minute waiting,
Okay.
which is mandatory. That's a headache. So that's why, yeah. Okay, so you just join there.